Hi, I'm Pat Kelly. Okay, in this problem, we're asked to evaluate the triple iterated integral. So you can see that staring at me, ready to go. And when you do these problems, really what's just key in terms of remembering is the order of integration. The differential elements that you have here, you always work in order from innermost out. So I'm going to start with the dx and make sure you pair that with the appropriate integration symbol there, which is the innermost again. This is like bookends. So I'm going to do the dx with limits from 0 to 1 first. When I'm done with that, then I'll take a step out and do the dz with limits from 0 to 2, and then take that last step out and do dy with respect to dy from 0 to 3. Okay? And it really should ring true to you, I hope it sounds familiar, to the work you did with double integrals, if you remember back to that type of work. It's really the same idea, except we have that extra layer. So let's get to it here. I'm going to work on that innermost layer first, the bookends with the x variable. So that first integration symbol I'm going to leave alone for now. The second integration symbol also leave it alone for now. But that third one, I'm actually going to do some integration right now. And when we integrate with respect to x, your other variables are just held constant. Okay, so integrate as if they were constants. So now the first term I see here is x. Integrated with respect to x, that would be x squared over 2. And then plus, because of that plus. And when I integrate the y, if it's a constant, that's going to be x times y. And similarly, that z is going to integrate to x times z. Okay? Now, mostly for bookkeeping, to keep yourself organized, you want some kind of grouping symbol there. And I'm going to use my square braces, because then I can also indicate those limits of integration. You don't want to drop those. From 0 to 1, I can put here from 0 to 1. And that's it in terms of the innermost work. Now don't forget the other layers. So the next thing I'd have is dz. I'll write that. And then also dy. Okay, next step down. I still have my integral from 0 to 3. I still have my integral from 0 to 2. And just within that square brace expression, I'm going to do my limits of integration, plug in the top, and subtract what happens when I plug in the bottom. You know, age-old calc stuff, right? So I plug in a 1 for x, and I get a half. Plug in a 1 for x. Plug in a 1 for x. Okay, and then subtract what happens when you plug in the 0, and you gotta love zeros, right? Because that's going to go to 0 and 0 and 0. So I'm not really subtracting anything. So I think I'll slap some parentheses around that and pick up with my dz dy. Okay, all good. Continue to the next layer. The next innermost layer are those z's, integrating with respect to z, with limits of integration 0 to 2 for z. And as I integrate, I'm only integrating with respect to z, so anything else I see will be held constant. So 0, 3, I'll leave that alone. Let me set up some square braces. The 1/2, but integrated with respect to z, will be 1/2 z. The y, constant though, I treat it as a constant, y times z. And then the z, integrated with respect to z, will be z squared over 2. All right? Square brace then, and I'll tack on my limits of integration 0 to 2. And then I'll also throw my dy in there. That'll be my next layer. All right? And then we'll simplify this in here by doing our limits of integration again. So let me go down. 0 to 3 still. Now I'm going to plug in that 2 value for z. So 1/2 times 2 is just 1. Plus, putting a 2 in for z, that's 2y. Putting a 2 in here, 4 divided by 2, that looks like a 2. Subtract what happens when we put in a 0. Again, blank, blank, blank. So I think I'm good. I'm ready to close parentheses and then tack on the dy. We're almost there. Let me see if I can even fit it in here. This will equal, now we're integrating with respect to y, and if you don't mind, I'll do this in my head. 1 plus 2, that's 3. And if I integrate that with respect to y, that's 3y plus 2y, but integrated is just y squared. And then I do still have my limits of integration, 0 to 3. We're in the home stretch. This equals 3 times 3 is 9, plus 3 squared is 9. Subtract what happens when you plug in the 0, which is going to be 0 again. And I've got an answer, 18. Okay, hope that helps. Try some more on your own.